One of the first things you have to do whenever you're working with electronics is decide what type of multimeter do I need? Like, which type of multimeter do I buy? And if I have multiple meters, which one do I use for the project that I'm working on? So in this video, I'm going to talk about 5 main concerns when looking at selecting a multimeter. The first thing to consider when you're looking at a meter is, do you want an auto ranging meter or a manual ranging meter? So the difference is, when you go to measure something with the auto ranging meter, you're just going to go and you're going to select the function that you want to measure, say resistance or DC voltage. But with the manual ranging meter, you actually have to tell it the general range that your voltage or your resistance is going to be in. So for instance, when I come in here to take a measurement of this resistor, I come in and it automatically finds the range and dials in 230 ohms. With my manual ranging meter, I have to select what range I need to be in on the dial. So I need to understand what the correct ranges are, and then I can come in here and get a measurement of my resistor. Now this leads to an interesting question. What happens if we do not select the right range? So let me show you. First, I'm going to show what the auto ranging meter does when I measure this battery. All right, 9.76 volts. So I'm going to set my manual ranging meter to the millivolts range. Come in here, get a measurement of my battery. Oh, look, I don't get a reading, open line. So that's telling me this is out of range. I got to change my range. Okay, I got to keep changing my range. Oh, there we go. Okay, so these things are just not as good. They're dumber, and I never recommend buying these manual ranging meters if you can avoid it. Obviously, the reason these exist is to save a little money, but nowadays you can get a pretty good auto ranging meter for just an extra $10, $15. So I almost never recommend these unless you absolutely have to save the money or you just have it lying around. I don't recommend these. Now, when selecting your meter, the next thing to think about is what types of functions do you want your multimeter to have? All meters come with certain basic functions. For example, almost all meters can measure the following: voltage, resistance, and current. Another common function is continuity testing. Continuity testing tells me if there's a low resistance path between these two probes, right? So if I put this on something metal or any type of metal, typically we're going to get, right? And different meters will have slightly different resistance values at which that'll beep. Another function you may want to have on your multimeter is the ability to measure capacitance. So if I come over here and I set this to capacitance, I'll get a reading of 947 microfarads. Other meters like this manual ranging meter doesn't have a capacitance function, so you wouldn't be able to measure that. So this function is not as common. This is the diode testing function, and you can see my meter on the right side does not have that function. If I come in here with my probes, I can measure the voltage drop across that diode. Another nice function to have on your multimeter is the ability to measure temperature using a K-type thermocouple. So if I set this to measure temperature and put thermocouple in, I can get a temperature reading. Now the temperature I'm reading is based off the temperature at the end of this wire. If you're an electrician, you might be interested in a function called volt alert, which if I turn this over here, I can put this near something that's got line voltage and it'll alert me. So if you want to see if there's power behind the wall, power's still in the outlet after you shut the breaker off, that can be a nice little function to have. Another nice feature to have on your multimeter is the ability to measure frequency. So right now I'm measuring the frequency of line voltage coming out of the outlet at around 60 hertz. Now the next thing you want to think about when selecting a multimeter is understanding the ranges, the accuracy and precision of your meter. And all those things sort of work together, give you the best information for whatever industry you're working in. And I don't want to go too deep a dive into this, but the main thing is understand what your meter was created to measure, right? Each meter is going to have some specific category or industry that it's trying to sell to. So if you understand what industry your meter is trying to sell to, you can understand what that meter's intended use is, and then select a meter that fits your use. So let me show you some practical applications of how this plays out. Right here, I'm going to measure the current with my 3 different meters right here. So using my Agilent meter, you can see I'm measuring 4.39 milliamps. But now if I come in and measure the exact same circuit with my Fluke 117, I'm only going to measure 0.004 amps. Because the range of this meter really wasn't designed to measure the milliamps range. This meter's designed really for electrical work, where you're not going to be measuring that low of currents. So this meter is going to do a much better job of measuring milliamps, and this one can even measure really good to the microamps. So this thing can do quite a bit, and it can measure amperage that this meter was never intended or designed to measure. Now you may think that this cheap meter can't compete with the Fluke 117. Now because this meter was designed for low voltage DC circuits, it can measure to the milliamp range. And in fact, it even has a step lower to the microamp range. So because this meter was designed to be able to do that, you can measure into lower ranges and you can get more precision values than you would with this more expensive Fluke meter. But this Fluke meter was never designed to measure those types of currents. That's why whenever you buy a meter, you want to understand what kind of ranges you're working in, what kind of accuracy and precision you need to do the job that you're performing. So let's take one more look at why the range and the precision of your meter is going to matter. This time, let's try to measure a 1 nanofarad capacitor. So this Fluke 117, it can get down to the 1 nanofarad, it can measure it, but you don't get any more information than just that single digit. But with your Agilent, you get about 3 extra digits there after the 1. But even more interesting is if I take this Milwaukee meter and I turn it to capacitance mode and I measure the capacitor, I don't register anything. Okay, so obviously this meter is not capable of measuring down to the 1 nanofarad range. All right, the next thing you need to consider when selecting a meter, do you need a true RMS meter or does it not really matter? So if you're working with DC signals, something that's not a true RMS meter is just fine. True RMS starts to matter when you start working with sinusoidal signals. All right. Now, if you have an ideal sinusoidal signal, this type of meter will still work. It'll still get a very accurate measurement. And in some cases, it can actually get a more accurate measurement. But that would be for a perfect or ideal sinusoidal signal. The true RMS can deal with signals that are not ideal or sinusoidal signals with large DC offsets. So what happens if you use this with a signal with a non-sinusoidal signal or a large DC offset? Well, you're going to get a reading that is not accurate, like really far off. Like it can be 20, 30, 40% off, depending on the situation. So, that can be kind of dangerous because you don't know what the value is anymore. You're kind of giving yourself a false value. So anytime you can get a true RMS meter, that's obviously a better option, but the true RMS meters are always going to cost more. However, like I said, if you just work with DC signals, then you really don't need a true RMS meter. The final thing to consider when selecting a multimeter has to do with the physical design, the robustness of the meter itself. So a couple things to note. All right, does your meter have a separate port for amps? Okay, so if you look at this meter, you can see there's a 10 amp fused port here, input jack, and right here you can see that the milliamps range has its own, is combined with the voltage input jack. This is like the worst case design, and there's some serious safety reasons why you don't want to do that. Look at a meter like this, you have a separate input jack for amperage, microamps, and milliamps, and then you have your voltage, resistance, and other functions input jack over here. So this is like an ideal situation, I would say, for your input jacks. You can see right here from this type of meter that you do have a separate input jack for the amperage range, but you don't have a milliamps and microamps range. So that's cueing you in to the fact that this meter doesn't measure in those ranges. Another thing just to consider is just the ruggedness, the actual feel of the meter. So most meters nowadays come with some sort of rubberized case around them. Even this really cheap meter does have this rubber case around it. But certain meters are going to be rated or more rugged than others. This meter is IP54 certified, so it's water and dust resistant. So you can put this thing through some paces and it'll still work pretty well. Another thing to consider is the physical size of the screen, right? So you can see on this screen, I have a very large screen and it can tell me a lot of information, right? It even just has a secondary display. It tells me the units. It has a bar indicator. So there's a lot more going on in this display than if I look at this meter right here, which is just giving me 3 digits. So here's the reality. If you are working with low voltage DC, and I consider that anything less than about 24 volts and below, low voltage DC circuits, and you're just doing hobby type work, a cheap auto ranging multimeter is going to do the trick. And I'll put my recommendation for that in the description. You can also use meters like this, these manual ranging meters. I don't recommend it. I say spend the extra $10, $15 to get the auto ranging meter. It's totally worth it. But as soon as you start measuring higher voltages, okay, line voltage and above, I do not recommend using these cheaper meters. They're not made to deal with that. I mean, technically you'll see like, this will say, oh, this is a category 1 and a category 2. 300 volts, 600 volts. Yeah, no, there's no way I'm putting 600 volts into this meter. That's crazy. It's just not designed properly for that. And if we could go into a whole explanation of taking it apart and looking at why it's not and how it's not fused in certain locations and how this resistor is just going to blow up once I put more than 500 milliamps of current through it. So yeah, I do not recommend these meters for higher voltages, and it's just too easy to leave the probes in this input jack and accidentally run too much current through your meter. So these meters can easily get damaged if you're dealing with high voltages. So we've talked about the main things you need to know to select a meter, and I'm going to put my recommendations for meters in the description, so make sure to check that out. But here's the thing. Now, let's say you want to start investing a decent amount into meters, like you're going for the 200 and above level meters. I'm going to start talking about some of the more nuanced things you want to look for in a meter. Okay, another pro consideration is how fast does your meter check continuity? So I'm going to test these from right to left just to give you a sense of the different responses you can get. So this one, you can see it lights up sometimes without beeping, which is not very good if I go so quick with my probes. So it can miss some quick touches, which if you're dragging those across the circuit board can matter. Let's try these real quick. Oh, that noise is a little rough. So this one's quick, but the noise is sometimes so, it's almost inaudible if you go quick enough. The fluke one beeps real quick. Like I can't go fast enough to miss that beep. So the fluke is very quick with continuity testing. And with the Milwaukee, yeah, that misses quite a few. If I go fast enough, that Milwaukee does not pick up continuity. So that's another thing to consider when you're using your meter. If you're testing circuit boards, right, and you want to drag your probes across the circuit board to test for continuity, that's something you want to consider. Okay, I had each one of these meters measure the exact same resistor, okay? Now, when I measure the resistance, I went ahead and pushed hold on all 3 meters, so they're holding the same measurement. And what we can learn from this is each of these meters displays a different amount of digits. So this has to do with the amount of counts that a meter has. So if you ever see a meter and it talks about the counts, this is related to the counts of a meter. I recommend around 6,000 counts if you're going to get a meter. But the reality is the more counts you have, the more digits, the more information you can display. So you can see I'm only displaying 3 digits of information on this meter. I have 4 digits of information on this meter, and I have 5 digits of information on this meter. So the more digits of information you have, the more precision you can have in your measurement, and you can see changes, small fluctuations or small variations of your measurement. And that can apply not just to resistance, but all of the other functions out there. Another consideration when you're getting a meter is how easy is it to change the batteries and the fuse, and what type of fuses are being used. So for this meter, you actually have to take the whole thing apart just to get to the battery and the fuses. It's sort of a pain. With the Fluke meter here, I can easily change this battery. There's just one screw holding it in place, and it's really easy to take apart and fix. Getting to the fuses in this one, you actually have to take this rubber housing off and unscrew some things. So that's a little harder to get to, but it does use high quality fuses, and I'll show you those right here. So these are the high quality HRC fuses, and these things are much less likely to break apart and rupture if they get a lot of current. So when you're using a lot of other meters, they use cheaper glass fuses that can break apart. But this is actually a really nice setup right here in this meter, because you have all the batteries you can change out, and you have access to the fuses. And also the fact that the fuses are sort of in their own, they're kind of protected from the rest of the board a little bit, is a nice feature. So another thing to be aware of when you're purchasing a meter is how quickly your meter responds to changes in voltage or current or whatever you're doing. So let's go ahead and change the voltage here. And you can see that my meter on the left responds, my Agilent meter responds very quickly, whereas some of my other meters, my Milwaukee and my Fluke, respond a little slower. I would say the Fluke's faster than the Milwaukee. You know, if I do big changes, you can see it actually takes a little time, especially when they has to rearrange into the correct range. But my Agilent meter is just like spot on, super quick refresh rates. So here's one example of when the accuracy can have an effect, right? So you can see my Fluke and my Agilent meter, they're in agreement. With the Agilent meter, I get an extra digit of information. Over the Fluke, I get one more digit past the 4 there. But with my cheap meter here, I get what? I get, while I do get 2 digits past the decimal point, my last digit it's not correct. While it's not a terrible thing to have that extra digit, it's also not giving me correct information. So that allows me to still see changes in that last digit, but I can't be confident necessarily in that digit. And how confident you can be has to do with the exact accuracy of a meter. So actually, as I didn't catch this at first, but I wasn't looking over at my readout on my Agilent power supply here. And if you look at this supply, it seems to be actually kind of in the middle of, this is reading a little high and these are reading a little low. So yeah, I ran a couple tests real quick, and I can say that the readout on this meter is reading a little bit higher. I have a calibration sample, and I don't necessarily want to get into that. But if you're wondering why this did not match up, this readout is running a little high. All right, let's say we take a measurement of voltage with our multimeter. The question is, how accurate is that? And how do we figure out the accuracy of our meter? In the spec sheet, we can see it reads that the percentage of the reading plus the counts. So what we need to do is we need to multiply our reading by 0.5% or 0.005, and then we add 2 times the lowest count value. The lowest count value is the lowest resolution of the meter in the range that I'm in. So for this instance, my counts value is 0.01 volts because this digit is in the 0.01 volts range. So if I were to do this out, I'd get around plus or minus 0.0669 volts. If I was going to write that all out, I'd say the reading is equal to 9.38 volts plus or minus 0.07 volts. The reason I round it up here is because this reading is only going to that digit anyways. Begs an interesting question. What if you don't have the meter yet? How do you know what the reading is going to be? Well, you have to know approximately what your value is going to be, in the sense that if I'm measuring a 9-volt battery, I know that my meter needs to measure 9 volts. And if I'm going to measure 9 volts, I can figure out how many digits of information I'm going to get on my meter based off the counts of my meter. So if I have a 6,000 count meter, all right, and I start at 0 and I count by 1, this is the highest number that I can display. I can display 5999. What if I need to display a 6, a 7, an 8, or a 9 in this position, which is very possible, right? Just like in this case, where I have 9.38, I have to display a 9 in this position. I have to take information from this last digit. So I'm going to lose this last digit of information. So I'm only going to be able to display 3 digits of information if I need to go above the 5 here, which is exactly what happened with my fluke meter, and which is why I was only able to display 3 digits of information. So if you need to figure out the accuracy of your meter and you don't have the meter yet, you need to look at this counts number, figure out what your display is going to read, and then you can calculate an accuracy or an approximate accuracy in the ranges that you're working with. All right, I know this video is getting long, so let's wrap it up with a couple last minute things. One thing to think about is your probes themselves, the probes that come with the meter. So some probes, you can see they're unshrouded, and this one's not very good. This comes with a cheaper meter. Something like this is shrouded, which is good from a safety perspective, but maybe not so good if you're trying to get into an electrical outlet. My preference is these removable shroud covers, so that's a nice thing. But you can always buy different probes for your meter, so that's not too big of an issue. Another thing to think about is if you need data logging for your multimeter. That's not a particularly common thing, but if you need it, you're gonna pay a lot of money for it, so just be prepared for that. So I know that part of the video on counts was a little dense. Maybe I'll post another video that goes into a little more detail because I kind of ran through that real fast. But hopefully it made sense. And also make sure to check out our video over here that has tips on how to use your multimeter. I hope you enjoyed the video. Check back in with us later for more content.